In this part, I'll present the explore timegpt tabular and relational of deep learning assignment. So I'll be performing the various tasks here. First one is timegpt. So there are 5 different tasks, and for tabular there are two, that is generating a synthetic data and generating inference for the demonstrate inference for this. And also at the last, like, we'll perform the RDL and the rel bench task for this one. Are taking on real life GNN based model, and we'll fine tune it, and we'll try to run like how it works and etc. So let's go to the each and every part of this. So first one, if you start with the timegpt multivariant collab along with the long horizon collab with the example of a time series data. So this is the example of a time series data, that is multivariant long horizon forecasting. In this, basically timegpt capabilities to handle multiple time series efficiently in a multiple way, visualizing, forecasting and outputs confidence in intervals is better interpretability compared to other things, and compared to timegpt predictions against the traditional model for accuracy and interpretability. So this is all about that, and for here is the forecasting model, and here is the importing package will be performed here. So first we'll install the important and required packages and initialize the in next client, and post that loading the data set is performed here, and here is the plot for that, like how our data, the time series data is scattered, and here is the multiple time series forecasting, and this is performed here. So and this is the historical forecasting, and why is but the end like available models in Azure AI. So this is the visualization of that, and this is all about the multivariant and long horizon forecasting way. So here is the predicted like time gpt and the y-axis one. So if you move to the next part is the fine tuning with a custom data set. So fine tuning custom gpt is fine tuning gpt ipnb file. So basically this is the file which I have run in the collab with a custom data set for domain specific forecasting. So here is the fine tuning, and here is the importing packages, and here is the loading the data for loading the data. So and fine tuning will be performed here, and here is available model for this, like valuable and the time gpt, and controlling the fine tuning and the hyperparameters and etc. So adjusting hyperparameters like a learning rate and approaches for optimal results, and post that validating the fine tuning results will be performed here, and the fine tune models on a unseen test data to ensure the robust predictions. So this is the unseen test data, and these are the robust predictions like which I got from for this. And next one, we go to the anomaly detection. So in the basically the anomaly detection in the time series to detect the outliers and anomalies in this particular data. So basically anomaly detection, and this is the imported packages and the loading data. So it's similar to the previous steps. So all are same implemented here. As additional feature, we have implemented this with threshold based filtering to the flag anomalies. So as means it visualizes the detected anomalies with the detected plots for insights into the irregular patterns. So this is all about that, modifying the continuous intervals, and so it is the plot for the continuous, like unique id versus 0, and time gpt anomalies level is 70. So this is that. And next one, we go to the energy demand forecasting, or forecasting energy demand. So here is importing libraries, and so in this integrated a real work energy dataset for the training evaluation, and for highlighted models ability to predict the demands, spikes and dips, and aiding energy grid optimizations. So here is the visualization for that, and here is the training plot, and here is the one where we test the different and where we forecast basically the time gpt and the y intervals, and here is the examples and horizon, and here is the model for the result, and here is the matrices, that is nft and smap and etc. So next one we go to the Bitcoin part. So in the Bitcoin price prediction, so trained on historic Bitcoin prices data and for the future movements. And this is the data set which we have loaded for this, and we have discussed it real world application including trading strategies and marketing analysis. So if you start with the time gpt, so here is the our api key and other things. Visualizing the data and the all the things are here like azure ai, and it's same like a previous one, many steps are, but the models and the azure AI analytics are pretty much same for this. So anomaly detection wise, the plot, and this is all about that. So once that is done, then we move on to the tabular data. This is about 30 seconds of it, and yeah. So synthetic data generation. Presented original data distributions, statistical property in this synthetic data, validating the general data for machine learning pipelines and all other things. So it is importing tabular and CSV files and tabular data, and here we give the model equals to tabular and llm and all the features, and here is fit and train the model for this like number of approaches and wise, and from there like we predict the model, and here is the predicted and the head of the csv. So this is the synthetic data generation, and once the synthetic data is generated, this is all about that part. And post that we move on to the demonstrating inference on a tabular model with a zero shot hint. So for this particular part, we demonstrate this inference for an unseen tabular dataset using pre-trained model to perform task without adding the training, and highlighted the model's generalization ability across different domains and all. So here is installation part for this, and once that is done, then model loading and the setup is performed here, like adding that configuration, and to set up a torch a D type to B flow type 16, which matters a tabular training and eval step, and or else we get the errors in this. And creating your own data set is this one, and post predicting with the continuous targets is performed here. So as we see, here is the output for the prediction for sample wise, and here is the greater than 8p is between 700 to 750 dot, and that part is completed. Then we go into the relational deep learning task, where this is the last rdl and rl bench part, where in this gnn based model training for tabular prediction is used. So leveraging a relational data structures to enhance a model performance, and for evaluation and all, we use f1 score and showing its potential complex a relational task. So it is a loading numpy and training table, and note that the load data we do not require any deep learning libraries. Now we introduce the pytorch framework library, which use it for encoding individual tables into the initial node features. So this is the one where this is the bench model utilities, and splitting the data and rstore perspectives, and post that evaluating the model with a matrix like accuracy, as f1 accuracy will be tested in this, and as application of relational deep learning such as fraud detection and a recommendation system. So this is better for those kind of things. So here is our data, so and data races.df will perform that, and the tensorflow objects and the timestamp of each node will be performed here, and post that now we ready for an instance to load our data loaders. For that we import a pytorch genome, our gnn library is this one, and so it is the pre-training part where we assign everything and perform. Now we need to our model. So here is the model fine tuning using a pytorch nnn module, and these are the forwards, and these are the rest parameters and etc, and forward dist readouts is this one, and this is the model 2 device, and here we train and test the loop in this. Now we are ready to train. So here is the model trained for number of 10 approaches for this, and Here is the RMSE score and MA score and R2 for the best matrix visualizations, and these are the val matrix, validation matrix, and these are the test matrices for this. So this covers all the tasks of this. So yeah, thank you.